Hello guys, my name is Desmond and I welcome you to my lesson for today where we will be looking at mathematics. Obviously, as I've indicated, we will be starting a new chapter called Trigonometry. So ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important because Kwazi, what I'm about to say, it's massively, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, please, honorable members, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, lady. Okay, so what is it that we will be looking at in today's lesson? It's a chapter called Trigonometry. This word, trigonometry, these are combined Greek words. There are two words there, and they simply mean triangle measure. Triangle measure. So that means under trigonometry, we are looking at nothing else other than the study of the relationship between sides and angles. Trigonometry, triangle measure. So that means we are actually measuring a triangle. What is a triangle? A triangle is just a shape having three things. What are those things? Side number 1, side number 2, side number 3. It's not only the sides that we will be looking at, it also includes three things. Bantu bagiti. What are those additional three things? Angle number 1, angle number 2, angle number 3. So you will realize that under trigonometry, we are actually studying the relationship between three sides and three angles. So that's all that we will be studying under trigonometry. Remember, Bantu Bagiti, we are starting a very new chapter today, which is called trigonometry. So if you happen to miss this type of lessons and you do not catch up, you will find that we are actually in the middle of the ocean. So just in case if you missed some of our previous lessons, just make sure to catch up. In case if you can't find those lessons, what you can do is just to send an inbox to request those lessons, because there is always a starting point. It is not at all the times where you will find the starting point. So let's see. I've just indicated that under trigonometry, we are actually studying the relationship between sides and angles. How many sides? 3 sides. How many angles? 3 angles. So the reason why you might find trigonometry to be difficult, it's simply because you did not start at the starting point. And the starting point is always boring. So I am encouraging all of you guys not to never give up when you feel like the introduction it's boring, because everything builds up from the introduction. As you know, we start with an intro, and then from there we do some more complicated questions that you'll come across in your exams. So that's it, Bantu. But now remember, sometimes we have a triangle which has that thing. Sometimes we just have a triangle in its own shape. So these are the two types of triangles. But under trigonometry, we are looking at what we call a right angled triangle. How do you know a right angled triangle? That's when we see that. If you don't see that, then we don't know whether it is a right angled triangle or if it's a triangle, just a Listen to what Lerato is going to say. Lerato, what possible type of a triangle is that?
I think that's an isosceles triangle.
Isosceles, any other possible name to that type of a triangle?
So I think it's an isosceles triangle.
Isosceles triangle. Okay. Most importantly, whether we talk about scalene, we talk about isosceles or whatever, just remember that under trigonometry, we completely forget about those and we only focus on a right angled triangle. Here comes a question. Is this a right angled triangle? Yebo noma cha?
No, it's a triangle, but it's not a right angle triangle.
Do you guys agree with that response?
Yes.
100%. This is a triangle, but we are not sure whether it is a right angled triangle or not. Why are we not sure? It's because we don't have a statement which says it's a right angled triangle, and again, it doesn't have that sign of a 90 degree. But the moment you start having that, then we know that angle is 90 degrees. So sometimes some other learners, they just look at that and it does look like it's a right angle triangle, but it is not if it doesn't have that, because this could be 99.9 degrees. It is not 90 degrees, meaning it is not a right angled triangle. So now I'm just going to further my introduction based on that to say, under Unit 1, we study. This is where we are now starting. Unit number 1, we study right angled triangle. That's what we'll be studying. Right angled triangle. So let's maybe do that just as a symbol to say that's what we will be studying. So now it's in most cases where we might need to refer to what we call a Cartesian plane. What is a Cartesian? A Cartesian plane is this vertical line and a horizontal line. This one being called the x-axis and the vertical line called the y-axis. I'm pretty much sure that you have learned all of that when we started with our functions. So most importantly, along this x-axis, we have our angle there being 0. This is the starting point being 0. And then let's see, it goes like 0, 1, 2, 3, 4, 5, 6, 7, 89, 89, 79, 89, 90. So can you see? Now we are having 90 degrees. That was 0 there. So let's see. 91, 92, 93, 179, 180. So now the angle there, it is 108. Okay, let's see. From 180, 181, then we get to 270 degree. Okay, let's see. 271, boom, we get to 360 degrees. So that means along this horizontal line, we have 0 degrees, we have 180 degrees, we also have 360 degrees. And then along the vertical line, we've got 90 degrees, we've got 270 degrees. Very, very much important, ladies and gentlemen, over there. So now, what you need to remember is that on a Cartesian plane, we've got what we call quadrants. We've got what we call quadrants. The word quadrants comes from a quarter, meaning if you want to cut this into 4 quarters, this is how you cut it. So that means this is a quarter number 1, this is going to be quarter number 2, this is going to, I think, is 3 of those, meaning quarter number 3, and then here we have IV. So that means this is quadrant number 1, quadrant number 2, quadrant number quadrant number 3, and then you also have quadrant number 4 there. So on this Cartesian plane, Bantu Bakiti, this is where we normally represent our right angled triangle. So let's see, how do we represent our right angled triangle? We have this line starting from the origin, which may start from there and goes in that direction. Otherwise, from there in that direction. Otherwise, from there in that, or from there in that direction. That line, it has got a name. It's called terminal side. But to keep it simple, let's call it the radius. It is either you call it the radius or you can call it hypotenuse. You will understand why we might need to refer to it as the hypotenuse. So from that line, that's where you form a right angled triangle. So can you see, if you draw a vertical line which forms a 90-degree angle there, that's when you have this side, and that side. So that means you're having 3 sides, where this one I've just said is what we call hypotenuse. So that means you will need to know what is the name of that side, what is the name of that side, which is what I'm going to then explain to you. Most importantly, here, this is how you can form a right angled triangle, with that being the hypotenuse or the radius. Also here, you draw that line forming a 90 degrees, then you have 1, 2, 3 sides. Also here, you draw it in that way, forming a 90 degree, then you are having one side, and there is another side. So that is how we represent a triangle. Not just a triangle, but a right angled triangle on a Cartesian plane. I'm not sure if you guys are able to understand what I'm explaining, but wait, guys, up to this point, are we still on the same page, or is there someone who's got a question before I go deeper? I'm not sure if Libandla Nkulunkulu is able to understand and hear what I'm saying there. Guys, are you still there? Are we still together? Do you guys understand what we are doing there? Or is there someone who's got a question or no question at this point? I got a response from someone saying they understand. Is it everyone who's on the same page as me on that one? Because I'm about to now remove all of that and explain further. Remember, guys, I'm not expecting everyone to fully grab everything that I'm explaining to you now. what I need you guys to do is just ukuvula amadlebe. Just listen very carefully and look at what I'm presenting to you. I'm telling you guys, it's in most cases where theory makes sense when we deal with exam type of question papers. So remember, guys, I will at all the times remind you that what I'm doing, it's what I know that it works. It's something that has worked for me. So I do know very well that you need to firstly study, do an introduction, and then from there, start treating exam question papers. That's if you don't want to struggle during exams. Don't spend much of your time studying a textbook. Study a textbook, give yourself enough time to study the textbook, and then from there, spend much of your time on treating previous exam papers, because that's where the trickiness lies. That's what you'll be expecting during your examination time. They don't use textbooks to set exam questions. Okay, so let's see. In a right angled triangle, each side has a specific name. This is very, very much important, Bantu Bakiti. Let me draw that. This is a triangle, but by the look of things, this is not a right angled triangle. So that means it's not what I'm talking about. That's why I'm going to remove it and draw a right angled triangle. How does a right angled triangle? It doesn't matter whether it is leaping or whether it is dancing or whether it is busy doing whatever. As long as it has that, it is a right angled triangle. Listen very carefully. In a right angled triangle, each side has a specific name. So that means this side has a name, that side has a name, that side has a name. You might find that this name is called a madrume. You might find this side is called Katuchero. You might find this side is called Kwazi. Unfortunately, they did not name those sides using African names. I don't think they used African names. Even if they did, but it's fine. We'll find out what are those names and which name goes to which side. There's a very straightforward name called hypotenuse. Which side is hypotenuse, and how do you know that side is hypotenuse? Always, when you say a side is hypotenuse, there must be something telling you that this side is hypotenuse because of 1, 2, 3. It doesn't matter if it's because of 1, 2, 3, 4, 5, 6, but what matters the most is that there should be something telling you that this is the hypotenuse. What tells you that a side is hypotenuse? It is that corner there. You see, the side which is opposite to that corner, it is the one which is hypotenuse. So that means this is name number 1. Then, what are the names of these two sides? We have two sides, Bantu Bakiti. The other side is called adjacent. And then the other side, which is the last side. Remember, only 3 sides, only 3 angles. The other side is called opposite. But now, since I've said it's always easy to identify hypotenuse, how do you know which side is adjacent? How do you know which side is opposite? So that is why in every triangle they use the letters. For example, they can say in capital letters, letter A, letter B, letter C, so that if you want to talk about that side, you're going to say BC. If you want to talk about that side, you're going to say AB. If you want to talk about that side, you don't say CA, but you say AC, because alphabetically A comes first. Here comes a question. between these two sides, which side is adjacent and which side is opposite, and how do you know which side is which? Just like I've explained, you say this side AC is hypotenuse because it is opposite to that 90-degree angle. So now, which side is which?
So I think it's partially confusing
Hey,
to
hey,
identify
Lerat,
the
Lerat,
side.
Lerat, 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 Lerat. Oh, hey, maybe let's give our newbies an opportunity to participate. I know you, Lerat, you're one of those who are being bought because I think you're doing this for the seventh time. Maybe, let's see, we've got Sean Piri on the line. Sean, are you sure you don't want to guess, honorable member? There is no Tando. We also have Tuli the Matulis. Charlotte is there, Umi is there, Busisi is there. We also have Sibusi Zomaha. Kwazi, do you not want to guess which side is which, honorable member? I'm not sure if there's someone who wants to guess which side is which.
So I think that the BC is an
Mm.
adjacent because it's opposite to the hypotenuse.
What I like about your participation, honorable member, it's because you say something and other learners are able to notice something. And based on my response, that's how you are going to learn. So, this is what happens, honorable member. In this case, you can never tell which side is which until I say with reference to that angle or with reference to that angle. So that means quasi the maquazis. You need to know when I say which side is which, ask me this question with reference to which angle. Then I'm going to say with reference to angle C. Then you're going to say, okay, with reference to angle C, this is the side which is adjacent. Why? Because it is adjacent to the angle. And then this side, it is the one which is opposite. Opposite to what? Opposite to that angle. I'm not sure if it makes sense, Bantu Bakiti.
So
The
that's
Makwazis,
noted that. Okay,
it,
now I know. So thank you.
it makes sense, nay. So, the problem with most of the learners is them not knowing which side is which and how do you know which side is which. Then this is you in grade 12, grade 11, grade 10. Under this chapter, you're always lost and it feels like it's difficult simply because you do not know how to identify the sides. You do not know these basics that I'm telling you or that I'm teaching you today. Someone is going to join my lesson, let's say in 2 weeks' time. They will find us somewhere in the middle of our lesson, probably solving exam questions. And if you don't catch her, Bantu Bakiti, you might feel a little bit lost. It is not because you are lost. It's because you started not at the starting point. That is why I always encourage all honorable members to always catch up so that you can start where we started. In that way, you'll be able. Okay, here comes a question. Is this a right angled triangle? Yebo noma cha?
No, sir.
Okay. Why are you saying no? So this is how you respond. It's because we don't have a statement which confirms it is a right angled triangle. And also on that triangle, we do not see the 90-degree sign. So next time when I ask, you can either give that reason or that reason. So now this is what I'm going to do. Is this a right angled triangle? Obviously, yes. So now I can say which side is which. Which side is which? What is the name of which side? Truly, can you now see the importance of having letters? That is why examiner has to say that is A, this is B, this is C. That's why you guys are quiet. You are quiet deliberately because you can't describe that side, or that side. But the moment I say A, B, and C, just know that those letters are not there to confuse you. It's not part of the trickness of the question. They're just there to guide you in terms of which side is which. So now you tell me, which side is which? Which side is hypotenuse? Which side is adjacent? Which side is opposite? Anyone? Lerato, you can now participate, honorable member. It's fine.
Side BC is hypotenuse.
Side B. Why are you saying it's hypotenuse? Hey, Charlotte, did you run away, honorable member? Waze kanjani ukuthi BC it's hypotenuse? Anyone who can respond to that question, if you agree, BC is hypotenuse.
It's opposite to 90 degrees.
Cosec is opposite to 90 degrees.
100%. It's opposite to 90 degrees. And something interesting about hypotenuse, let's maybe state the facts or characteristics of hypotenuse. Number one, it is opposite to 90 degrees. Number two, it is the longest side. When I say the longest side, it means if this side is 2 meter and this side is 3 meter, this one is going to be longer than that 3 meter. If this one is 1 million millimeter, this one is 2 million millimeter. This one, it has to be more than that 2 million millimeter. Those are the characteristics. But now, which side is adjacent and which one is opposite? Which side is adjacent? Which side is opposite?
Sir, please give us the reference angle.
100%. 100%. Okay. Hey, Bantu Bagiti, something happened and I'm not really sure of what happened. But hello, I come back. Are you guys still there? Can you clearly hear me before I continue?
Hear you, sir.
Yes.
Okay, so Lerato, I was saying with reference to angle C, then which side is which?
Oh, sir, AB is the opposite side.
Waze
And
kanjani? Waze kanjani?
oh, sir, C is the reference angle and it's opposite to AB.
So, you do know very well that AB, what is AB again, Lerato?
Opposite side.
Yeah, so the reason why you say is the opposite side, Lerato, it's because it is opposite to the reference angle. So that is the response that you give when I say wazeka njani ukuthi that side is the opposite. It's because it is opposite to the reference angle. So that means this is the obvious side. So always when we label a right angle triangle, this is the format that we go. Firstly, we identify the hypotenuse, and then secondly, we look at the reference angle to identify the opposite. And then this one is what we call an obvious side, being the adjacent. So that's how you label a right angled triangle. I'm not sure. Is everyone happy there before I go deeper?
I have a question.
Yes.
Do they usually give us the reference angle every time?
At all the times, the maumis. But examiner is smart. In a textbook, they will always give it to you as a straightforward angle. But in exam, somehow you might need to calculate that angle, and then somehow you work it out with another angle, and somehow it becomes something tricky. But what matters the most, whatever that you do, it comes down to the basics that I'm teaching you now. That is why the maumis, as soon as we are done with this introduction, we will then look at exam questions to check how is it given, in what format, in which manner is it given during your examinations. So what happens is someone is going to say, today's lesson was nice, I understood everything, which means I'm ready for exam. I'm telling you, if you approach these things with that mentality, you will see flames during your exams. You will feel like calling firefighters because of the flame or the smoke that will be coming out. So just make sure that with you understanding my lessons, it doesn't mean you fully understand what gaan aan. It's in most cases where you might understand all of my lessons, but it doesn't mean you are ready. You are only ready after you've attended all my lessons and after you have practiced by yourself and got to a point where it feels like you don't even need to ask me any question, because whatever that you did, it was exactly as they did in the memo. The Maumis, you are answered, most honorable member. Do I continue, or is there anyone who's got a question?
Yes, thank you. We can continue.
Okay. So now let's move on to unit number 2. It is not in today's lesson where we will be doing exam questions. So let's see. Under unit 2, this is what we now look at. Obviously, we have what we call definitions of trigonometric ratios, which is what we'll be looking at. Remember, in trigonometry, ratio between sides are given certain names. Now I've introduced a new word called trigonometric ratios. Note it down. Trigonometric ratios. So it's in most cases where you will hear me saying trigonometric ratios. Trigonometric ratios. Trigonometric ratios. Okay, what are those and how many trigonometric ratios are there? But before, you need to understand what is meant by a ratio. Ratio means something over something. So since we are dealing with a right angled triangle, and I just said we are looking at the sides, of which, let's say, with reference to that is going to be the opposite side, this is going to be adjacent side, this is going to be hypotenuse. So when we talk about the ratio, we obviously talk about one side over another side, or one side over another side, one side over another side. So Now, because we are talking about trigonometry, that's where we remember that under trigonometry, we study the relationship between sides and angles. So that means to derive trigonometric ratios, we will need to use those sides. How many trigonometric ratios do we have? We only have 3. So this chapter is all about 3 things, Bantu Bakiti. 3 names, 3 sides, 3 angles, 3 whatever. 3 things. Okay, we have what we call a sine. Sine is called trigonometric ratio. We also have what we call cos. We also have what we call tan. Since we talk about trigonometric ratio, meaning something over something, the moment you say the opposite side over the hypotenuse side, this ratio is given a name. And that name is sine. So that means sine, it's actually equals to opposite over hypotenuse. And then when it comes to cos, it is the one which is adjacent over hypotenuse. So that means adjacent over hypotenuse, it is the one which is cos. Its trigonometric ratio is called cos. And then tan is obvious. It is the one which is opposite over adjacent. So that means this word sine, cos, tan is called, or those 3 are called trigonometric ratios. So if someday I say, how many trigonometric ratios do we have and what are those? You're going to say we have 3 trigonometric ratios and we have sine, cos, and tan. Those are the 3 trigonometric ratios. Hey, I'm not sure if I'm losing you, Bantu Bakite. Guys, are you sure we are still together there? Sasa sonke Bantu Bakite.
Yes, sir.
Lerato, let's now try to find a possible way of cramming those. I think something like Sokatua or how do you guys cram those at your schools? Is it Sokatua?
It's Sokatoa, sir.
Yes, sir.
Yes, I think most of you. How is it written? Is it like that? So ka toa. Is this how you crammed it?
Yes, sir.
I'm pretty much sure that it's everyone who crammed it that way to say. For sine is opposite over hypotenuse. For cos is adjacent over hypotenuse. For tan, it is that part. So that means 1, 2, 3. These are what we call the trigonometric ratios. And this is the name of the side. These are the name of the sides. Okay, I'm very much happy that all of you guys have crammed that. So now, let's introduce another heavyweight, Bantu Bagiti. Listen very carefully. Libandla la kaNkulunkulu. Volani madlebe. Ngifuna ukukhuluma amagama amanzima. Listen very carefully. We've got what we call the reciprocals of the trigonometric ratios. Yes, yes. Bantu Bagiti. Reciprocals. Of what? Of trigonometric ratios. I normally call this the cousins of trigonometric ratios. I'm not sure if you guys have ever heard of something called Cosec, sec, cot. The Maumis, are you hearing these three for the very first time, honorable member, or have you heard of those before?
No idea, sir.
No idea. Okay. Now, I just said we have this honorable member and that honorable member and this honorable member. These honorable members are what we call trigonometric ratios, and they have their relatives, they have their cousins. Mathematically, we call those reciprocals. So now, the Maumis, it's a question of whose cousin is whose. Since the Umis is seeing those for the very first time, I'm going to explain to Umi. If Umi understands, I'm going to make an assumption that it's everyone who understands. If there's someone who does not understand, then ask me. I'm going to try and explain differently. But this is what normally happens. It's in most cases where whatever that I explain, it's easy. Why? Because I learn these things from you guys. That's why I like master classes. There was a learner, I think last year or last of last year, called LB, who actually gave us the simplest way of cramming these things. The Maumis, let's have a look. What is letter number 3 for this?
Letter number 3.
Yes.
S.
This is cosec, this is sec, this is cot. What is letter number 3 for this?
S.
So that means cosec is the cousin for sine. What is letter number 3 for sec?
E.
Hey, amadlozi yami avumi the Maumis. What is letter number 3 for sec? The Maumis, letter number 3 for sec. What is it?
C.
Yes, that means sec is the cousin for cot. No, for cos. So now, what is letter number 3 for cot?
T.
That means cot is the cousin for tan. Does it make sense, the Maumis?
Yeah, it's coming.
Yes. So, in short, it means if you are given a cosec and you want to know if cosec is the cousin of sine, cos, or tan, you look at letter number 3. Then you see is S. So that means cosec is the cousin for S for sine. And then here you have C. That means C for cos. And then here you have T. T for what? For tan. So what are the reciprocals? The reciprocals, you just swap this thing. Can you see for sine, it's opposite at the top, it's hypotenuse at the bottom. That means for cosec, it's going to be vice versa. It's hypotenuse at the top and then is opposite at the bottom. And then for sec, you just swap those. So that means sec, it's going to be, what is it? Hyper over adjacent. So that means for cot is the cousin for that, you swap those. So that means for cot, you are having adjacent at the top and then opposite at the bottom. I'm not sure if the Maumis, if it's still coming, or has it arrived, honorable member, or is it still coming?
No, I get it. Thanks.
Hey, you get it. If you don't get it, forget about it. So now, anyone who's got a question, Bantu Bagiti, before I go deeper, or Do you allow me to go deeper?
No question.
Sibusiso maham. Are you sure, honorable member, you don't want to ask me a question there? Even if you say, how are you? It's a question, honorable member. Sean Piri, are you sure? Mtakaba ukuthi awuna
No
umbuzo.
question.
Bosisiwe, are we okay that side? Hey, Tuli, why is it like you're watching our perfect wedding that side? Are we together there? The Matulis? No response. I'm not sure if we're still together, Bantu. Matapelo, are you there? Can you hear me, honorable member? I'm not sure if you guys are still able to hear me because I'm not getting a response. Okay, so now let's
I hear
move
you, sir. Yeah.
on. Okay. I'm just not sure if I have to add this at this stage, but maybe let me not edit here. I will edit some other time just so that you guys are not confused. Okay, let's see. We are now moving to unit number 3. I'm telling you guys, I am telling you, if you can grab everything that I'm explaining now and try to catch up, when we solve for exam questions, you will never get lost. You will know that when I say this is the reciprocal, the cousin of trigonometric ratios, you will fully understand what I'll be talking about. But if you skip lessons and you don't catch up, you will hear me saying cousin of whoever and you will think it's a joke. It is not. Quickly, let's talk about what we call a special. You can either say special angles or special triangles. I'm just not sure what to call it, but maybe let me use a common name, which is special angle. In simple terms, special angles. So let's see, Bantu Bakiti. You need to know these special angles by heart. The first one, it is not given on the formula sheet, but you need to always know those. To say, when you are having 90-degree angle there, and if there it is 45 degrees, what angle is there? It has to be 45 degrees. I'm not sure if you agree with me there, Bantu Bakiti. Let me just quickly explain where that comes from. This is what they say. They are saying the sum mean it means when you add. So the sum of interior angles of a triangle are equals to 180 degrees. What that means is that when you add this angle and that angle and that angle, they must give you 180 degrees. So now we already know that this is 90 degrees. If this one is 45 degrees, automatically, or if you like, you can say automatically, this angle has to be 45 degrees. Why? So that when you say this plus that, it has to give you 180 degrees. So that is why I'm saying we have our first special angle where we are having a 45 degrees there. And they say you are going to have one there, and then the hypotenuse is square root of 2. It doesn't change. It's always like that. You just need to know it by heart so that you'll be able to apply it when necessary. This is our first special angle. You just need to have a look at that and never forget it. Let's have a look at another type of a special angle. So there is this one which has 60 degrees down there. And they're saying this one, you have 1 always as the adjacent. You have square root of 3 there as the opposite of that angle. And then you have 2 as your hypotenuse. Another one, it is this one, where you now have 30 degrees up there. So they're saying you are just having the same values as those there. It's going to be 1 just like there. It's going to be square root of 3 just like there. It's going to be 2 there just like there's 2 there. So what they normally do is to say, because economically it's difficult, instead of us having to draw these 2 triangles 2 times and wasting an ink, let's just combine those. Let's just combine those, because we realize there is 90 there, and you see there it is 60, and there it is that 30. So both of these, they have 1 there, they have 2 there, they have square root of 3 there. That is why some teachers will then not explain to you that, but they will say now you only use that and this one. So that means we only focus on 2 special angles, where there's that one of 45 degrees, which is 1, 1, and then square root of 2. It doesn't matter whether you write 45 there or you don't write it. So this is what you need to always remember. There's nothing much to talk about there. You just need to know that there's something that exists as a special angle. And a triangle of a special angle, to label it, you label it in that format. So, most importantly, in summary, in what? In summary. That means when we talk about the special angles, you should remember 30 degrees, 60 degrees, and 45 degrees. Maybe let me follow that order there to say 45 degrees and then 60 degrees. So the Maumis, this is what happens. For example, they're just going to say what is cos of maybe, let's say, 45 degrees. So you ask yourself this question: what is the trigonometric ratio of cos? Is it not adjacent over a hypotenuse? If that is the case, then on the triangle of 45 degrees, what is the adjacent and what is hypotenuse? Then you go to that triangle, you look at it, and you say, obviously, this is what is it? A hypotenuse. So that means already, you know, at the bottom you have square root of 2. And then now you need to know which one is adjacent. So whether you say with reference to that, then adjacent is 1. Whether you say reference to that, adjacent is 1. So that is why you are having 1, 1 there. So that means you're going to say 1. So now it is done. So what happens, the Maumis, is that they give you too many of, maybe here they will say sine 30 degrees, maybe they complicate it and say over maybe tan of 60 degrees. So that means you need to do the ratio for sine 30, where you look at angle 30 and you need to know which one is opposite, which one is adjacent. Then you write it there. You do for this one, of course, and then you do this one for tan. That's where it gets complicated. It is not complicated at all. It is just too much. You know, there are things which are complicated. There are things which are difficult. There are things which are just too much. So trigonometry, it is just too much. Not complicated, not difficult, not confusing, but it is all about you having too much. The question is, can you handle too much? Yebo noma cha? So sometimes you don't realize it's too much. It just feels like it's tricky because maybe you did not start at the starting point. Everything has got the starting point, and this is the starting point of trigonometry. I'm not sure if you guys are feeling what I'm feeling, guys. Me, I can feel some nice things. Okay, maybe anyone who's got a question before we do a very quick exercise, and then from there, I take any questions. Then I think what will follow afterwards will be load shedding on my side. But I feel like we might need to also continue with this lesson tomorrow so that we know that we have covered a lot. Then next week, if we have covered all the introduction, we start on answering exam type of questions. We don't waste time. We don't waste time. I never believed that I can limit my mind based on the program set at school. The Maumis, when they say at school we take 3 weeks to do introduction, it doesn't mean your mind is not capable of doing all of that in just a week or in just a day. It's about how much of time do you dedicate to your studies? How serious are you? Do you have someone who can explain to you things better to enable you to study on your own? Or are you just going to rely on the teacher? If you do rely on the teacher, what's going to happen when you do your first year? You're going to see disaster. You need to learn how to study by yourself. Don't rely on your tutor. Don't rely on your teacher. Don't rely on your parents. Don't rely on anyone. Rely on yourself. Train your brain to rely on itself. You are rich when you have knowledge. Because if you don't have knowledge, hello, I come back. Are you guys still there? Or did you run away? Ibandla la kaNkulunkulu. You can't go without collections, bantu bakithi. Isonto isasekhona eh, kumele sibonge uNkulunkulu manje ungathi lona lifuna ukubaleka. Hey, okay, there is the screen. Are you guys still there?
I'm still here, sir, but I can't hear you properly. Your line is breaking.
I don't see my screen. I don't see my screen as can see. But you can, but you can just be aware that is load shedding, which will continue tomorrow on. need someone just if you heard what I just said. It's no response to that.
Your line is breaking, sir.
It's breaking. Not agree with you, honorable member. And within a management and amount.